Hey guys, thanks for joining me for another Tech Talk Tuesday. Real special episode today. We have our first ever guest speaker for Tech Talk Tuesdays here at Pedestal Solutions. We're being joined today by Steven Borlè from Group Sia Technologies. Here we go.
You want me to go down?
I'm ready. Well, hold on, just a second. Are we in your shop area right now?
Yes.
Oh, well, we need our protective outfit then. You got to make sure you're visible at all times.
Well, Brent, I stayed here late to help you out with this, give you a good presentation. That's the reason I don't have a mask on, is I happen to be the only one here late at night.
Of course. Okay. Ready for the tour. Please show us the facility.
Hey, Brent. Thanks for giving me this opportunity. All right. So you asked me today, Brent, to give you a little bit of information on laser cladding, give you a look around our shop.
Yeah.
So that usually takes us about an hour. How long do you want me to do this in?
You got about 5 minutes. Yeah.
5 minutes. Okay, let's start with this. This is Group Sia. We got started in 2013. I came on board early in 2014, and I am one of the materials and welding engineers here. So we started out with one cell. We're now up to 3 cells, 2 grinders. And yeah, so let's start taking a tour and see some of the equipment we got here.
Awesome. Steve, before we get rolling here, I just want to ask a quick question. First off, tell me, what is laser cladding welding?
So laser cladding is a welding process that, unlike traditional welding processes where you're joining 2 parts, we're just melting some of a base material and then adding an alloy on top of that. So that allows us to take, say, a cheap base material that doesn't have good properties and put an expensive, high corrosion resistant or high wear resistant material on top of that.
Well, now that sounds really interesting. Next question. What industries would I find a use for this?
So a lot of different industries use laser cladding. That would include heavy equipment industries, oil and gas, agriculture, forestry, chemical processing. That would include stuff like pumps, centrifuges, all these. Essentially any industry or all industries experience wear and corrosion. So anytime you see that, that's an area that laser cladding could be used potentially.
Okay, that's awesome. That's a massive amount of opportunities out there.
So I'm a materials and welding engineer. So a lot of time I spend around here is actually looking at welds. And what I'll do is I will get a weld, we'll weld her up, something like this. We'll cut her up, we mount it like this into little epoxy pucks. We then use this grinder polisher to polish it up to a mirror finish. This is what a sample looks like that we'll actually look at. Take it over. We've got a hardness tester here, a microscope. Right here is looking at the microstructure of an actual tungsten carbide overlay that we've applied. The neat thing about this is all those little darker particles that you can see there, they're all between 50 and 150 microns in size. So they're tiny. And this is actually at our lowest magnification that we have on this camera. So we can really look at the microstructure in depth. So that's how I go about actually qualifying the different materials that we have. Now, the first cell that we had was this cell. And this is our OD cell. The reason we call it our OD cell is we can only do outer diameters on this cell. The reason for that is it has this big head here, as you can see, and for reference, what happens here is there's actually a diodes in this head, and these diodes are what are producing the laser. Out through this head, it goes through a few optics and then it comes out. And then what happens is there's these 2 beams, and that gives us an idea where they cross is where the focal point is. That's where we do our welding. Now, both these right here are powder feed plates. So powder comes out and it goes into the weld pool. And that's essentially the gist of laser cladding. We also do a little bit of laser welding and laser heat treating here as well, but we're just going to talk about the cladding today. That's the majority of the work that we do. This robot can move up and down this cell, so it can do up to 37-foot long parts. The diameters on this cell are about 4 feet in width, is the widest we can do. This is cell 2. This is the ID cell. This allows us to do the inside of parts by having this smaller head. It can go inside parts down to 2 3/8. In this case, the laser's coming out this front through this nozzle. And then this nozzle right here is actually the powder, where the powder is fed from. They meet up on the part where we're doing the work. It has a rail system here in order to take large parts in and out. So what we have is we have a cell that can go and it can pick up a part automatically as soon as you let it know what the diameter is, what the length of the part is, that sort of thing. It'll go down, it'll actually pick up your part.
Oh, I'm happy I'm wearing my PPE today. Oh, that's so cool.
So it'll pick up the part, and then what it's going to do is it's actually going to bring it over here to this sensor. Now, the neat thing about this sensor is every time you pick up a part, it's going to be a little bit different. It can't be 100% right every time or 100% the same. So what it's doing right now is it's just taking measurements of the height at one location. And what you can see as it's rotating is it's not staying completely level. And that's because it can't pick it up straight 100%. Or it's not, 100% correct when it picks it up, like I've already said 20 times. Anyways, it takes those measurements and then it's going to make some changes to what's called a user frame. And now this part can be located very accurately within a millimeter or so. So now the robot knows exactly where this part is located. It'll come, if we want it to, it'll go over to this preheater down here in the left, and it'll actually preheat it at a predetermined temperature for whatever time.
Using induction heating.
Using induction heating, yeah, whatever length of time we predetermine it. We use these pyrometer controls here, and that's how we actually measure the temperature accurately. The person now comes over here, getting ready to go under the laser head, goes under the laser head, does whatever welding it's set up to do. We'll then take it out, take it back over to the sensor, measure the height after cladding, and then we can make sure that it is actually building up as much as we're looking for. So
really fascinating out there. Now, let's say I'm a potential customer and I want to bring some business to you. Do I need to send 1,000 units to get interest with you guys? Like, how does it work if I need to do a laser cladding overlay for wear points?
That's a great question, because as you'll see in the tour, is we do all of our welding with robots. So normally robots are set up to do tens of thousands or at least thousands of parts. But what we really focus on here is doing small batch automation. So we use a lot of different techniques, sensors, to take something that may be quite complicated normally to program and simplify that program. That means that we do simple one-off parts, 10s, 20s, hundreds that are actually a really large batch for the types of parts that we see. So we can do a single part, we can do thousands of parts, anywhere in between. And a lot of that is because of our focus on the automation side and simplifying what is traditionally not known as a part that you would want to automate because it's too small in quantity, and really taking those and bringing automation to them.
Well, that's great.
Another area that we really focus on the automation is that repair area. So normally it's very hard to automate repair because every single part's different, and it's very hard to know what a part's shape like when it's been worn, right? Without using really expensive 3D sensors. So we use some of that 3D sensors and then other simplified ways to decrease the amount of time, effort, and cost to repair one-off parts that are worn down. But really, we do everything from tungsten carbide, which is wear resistant, or nickel chrome boron silicate alloys, to cobalt alloys such as stellites, polynoids. We also do Inconel, which is a very good corrosion resistant and high strength. It's really good mechanical strength. We do stainless steels like 316, 309, 431 is a martensitic that gives you some wear resistance.
But so you're telling me you can put 316 stainless steel in a powder and shoot it out for a weld?
Yes.
We're watching the longest Tech Talk Tuesday I've ever had and the first guest speaker ever. Thank you so much, Steven Borlè, for joining us and letting us learn all about what you do for Group 6 Technologies. Cheers, guys. Hope you have a great Tuesday and an amazing rest of the week. Take care.